You're about to hear perspectives forged across scaling, research, and go-to-market. Stick around for the synthesis pull at the end. It's brutally pragmatic. Welcome back to AI on AI, the show where we translate frontier research into practical moves for technology and business leaders, and pressure test the hype with sharp data. Today, we're unpacking the latest Anthropic Economic Index report, which traces AI's wildly fast diffusion, the uneven geography of adoption, and what enterprises are actually automating through APIs.
I'll set the stage from an AI economist lens. Adoption is stunning. About 40% of U.S. employees report using AI at work, roughly doubling in 2 years. And the hallmark pattern is concentration. Usage clusters in high-income countries and specific tasks like coding, with the Anthropic AI Usage Index tightly correlated with GDP per working-age capita.
From the system side, the data shows a meaningful usage shift. Code creation is up, debugging is down, implying better first-pass reliability and stronger program synthesis. That aligns with improved search and research features and more capable models that reduce back and forth. So workflows are compressing, not just speeding.
Wearing a business leader hat, the API lens is decisive. 77% of enterprise usage is automation dominant, compared to roughly half on the consumer surface. What's striking is weak price sensitivity. Higher cost tasks get more usage, so capability fit and economic value clearly trump marginal token cost in enterprise deployment.
The policy angle is sobering. High AUI countries may compound gains while low AUI regions lag. If productivity accelerates where adoption is already deep, we risk widening inequality. The flip side is targeted diffusion. Skills, connectivity, and public sector procurement can catalyze catch-up, but it must be deliberate.
And the data plumbing matters. The report finds a context bottleneck. Complex tasks demand richer inputs. Across tasks, a 1% rise in input length only raises output length by about 0.38%, so returns to stuffing more context are diminishing. Firms that can curate concise, high-signal context will unlock more sophisticated automations.
Let's dive into that automation versus augmentation shift. On Claude.ai, directive interactions climbed from roughly 27% to 39%, and overall automation just nudged past augmentation for the first time. What's happening on the ground?
Two forces, likely intertwined. Capability improvements reduce the need for iterative refinements, and user learning by doing increases confidence to delegate end-to-end. The micro implication is fewer handoffs. The macro implication is ambiguous. Displacement risk rises in automatable tasks, but workers adept at incorporating AI see rising demand.
Technically, this mirrors maturing single-shot program synthesis. Teams are using self-verification patterns. Think draft code, then test loops, static analysis hints, and quick compile-run checks. So the first draft is more usable. Add web search and research grounding, and you've got higher quality outputs without protracted prompt ping-pong.
Architecture matters too. Retrieval pipelines are evolving from naive top-K to multi-stage re-ranking with hybrid dense sparse search, smarter chunking, and doc-level semantic headers which reduce irrelevancies. You get sharper input context with fewer tokens, and that's precisely where the input-output elasticity findings begin to make sense.
On the enterprise floor, we saw a product team move from ask then fix to specify then ship. After instrumenting unit test generation and a code review rubric, first-pass acceptance in a new services module climbed by more than a third, while manual debugging minutes per ticket dropped materially, and time to merge shrank week after week.
The report says cost seems less decisive than capability in shaping business use. How should executives interpret that without getting surprised by their cloud invoices?
The key is that controlling for task characteristics, a 1% cost increase reduces usage only about 0.29%. In practice, leaders are optimizing for reliability, latency, and outcome quality. I recommend a simple heuristic. Prioritize tasks where the value of automation is structurally higher than context cost and exception handling combined.
Exactly. Latency and determinism are bigger levers. Engineering teams are using token caching and KV reuse, plus JSON-structured outputs validated against schemas to limit retries. Predictable interfaces and guardrail pass rates matter more to the product P&L than shaving a few percentage points off token spend.
I'll add a contrarian wrinkle. Price insensitivity may hold now because early adopters are in high-value tasks. As regulation embeds audit and liability costs, cheaper but more auditable flows may win. So capability wins today, but governance overhead could reprice the stack tomorrow.
Geography now. AUI shows leaders like Israel, Singapore, Australia, and the US outpacing their population shares, while countries like India and Nigeria are underrepresented. Even within the US, DC and Utah lead per capita. What should we infer?
The AUI correlates strongly with income per worker globally, and within the US, income explains only part of the picture. Local economic structure matters. California skews IT, Florida tilts toward financial services, DC toward document and career support. Low AUI regions show more automation-heavy usage, even after adjusting for task mix.
Policy playbook in 3 moves. First, digital infrastructure and affordable compute access. Second, workforce complementarity, practical training in AI-augmented workflows. Third, demand-side pull, public procurement for high-trust verticals. Coordinated sequencing helps latecomers leapfrog rather than follow a slow S-curve.
For emerging markets, there's a hidden wedge. Automation-first use cases can undercut entry-level job ladders. BPO and shared services must pivot from routine delegation to augmented judgment. Investing in retrieval over local knowledge bases and domain process memory can create defensible value beyond low-cost labor.
Technically, the leapfrog route is real. Offline agent testbeds with robust safety rules, localized prompt libraries tuned for code switching, and lightweight tool integrations can deliver reliable outcomes without heavyweight data centers. We've seen teams ship resilient flows on relatively constrained infrastructure. Let's pause on that 0.38 elasticity between input and output length. Why do longer inputs translate to less than proportional outputs? And what should architects do about it?
3 reasons. Information redundancy, model attention allocation that degrades in long contexts, and noisy context packaging. The mitigation stack is retrieval budgets, context canonicalization, and evidence tagging. Treat context as a product. Craft a domain ontology, hash canonical facts, and pipe only the deltas relevant to the task.
Plus, plan the query. Break tasks into sub-questions, fetch precise snippets, and stitch answers with pointer references. Hierarchical retrieval, query then drill, saves tokens and elevates relevance. Cross-encoders for re-ranking reduce off-topic passages, and you can cache context embeddings to avoid paying the read tax twice.
We saw this in a financial services deployment. KYC and policy Q&A moved from monolithic document dumps to segmented retrieval with policy anchors and scenario validators. Throughput rose over 30%, exception rates fell near 40% in pilot lines, and audit review time per case dropped after we added rationale pointers to source clauses.
The concentration evidence is consistent with an O-ring world. Any weak link blocks adoption. Usage follows a power law with Gini around 0.8486 across tasks. The best match tasks, coding, structured admin, explode in volume, while those needing cross-silo context or regulatory clearance lag, even if technically feasible.
So do we converge on a centaur future, human plus AI, or does automation swallow augmentation as models improve?
In operations, the centaur wins when tasks are interdependent. Think AI drafts, human ratifies, AI files, system logs. The human becomes the domain constraint optimizer. We're redesigning roles around exception handling and policy arbitration rather than raw production.
Careful though, agents running unattended can drift. Robust execution requires guardrails, stop conditions, sandbox tool calls, input sanitation, canary tasks, and back-off strategies. Every autonomous chain should degrade gracefully to a human checkpoint or a safe default.
Labor markets will feel it first at the entry rung. When routine drafting is automated, apprenticeships need rethinking. We'll need structured practice with feedback systems so juniors still build tacit skill. AI can be the tutor, but managers must redesign the progression ladder.
The empirical hints are consistent. Entry-level workers in high AI exposure areas are seeing relatively weaker outcomes. It's plausible that AI complements experienced workers who hold tacit organizational knowledge. The task is to broaden complementarity rather than accept bifurcation.
The state-level slice is fascinating. DC over-indexes on document editing and career assistance, Florida on business advice and fitness, California on IT and digital marketing, and Utah's elevated directive scores raised some abuse flags, but didn't change the headline patterns.
Exactly, and the broader point is product-market fit varies with local economies. Job seekers in DC use AI for resume polish and policy docs, while California's multilingual tech workforce leans on IT tasks. This heterogeneity matters for go-to-market and for public training programs.
On the enterprise side, we're seeing office and admin tasks surge through APIs, scheduling, CRM hygiene, invoice triage, especially when coupled with lightweight RPA. AI drafts the action and the bot executes with a policy check in the middle.
Architecturally, that's function calling into RPA. LLM produces a JSON plan validated against a schema, an orchestrator binds parameters to approved actions, and a runtime checks preconditions. You get deterministic execution and crisp telemetry for audit and rollback. Let's bring in a manufacturing case. What's working where physics meets paperwork?
A mid-sized manufacturer fused a neural code assistant with symbolic ESOP rules and a retrieval layer over equipment logs. Technicians received AI-proposed adjustments that respected safety constraints. After 6 quarters, maintenance cycle time decreased close to 30%, and unplanned downtime incidents dropped meaningfully with higher first-time fix rates.
That's where governance scaffolding pays off. Line of sight to data provenance, model versioning, and nutrition labels on outputs. Audits become traceable. Which SOP version, which sensor data window, and which model policy was in force when a decision was made.
Measurement is the bridge from hope to habit. What KPIs should leaders track to know if they're moving from experimentation to durable productivity?
Start with an internal AUI of sorts, usage per eligible worker normalized by role mix. Then track automation share versus augmentation share by process. Monitor Gini across tasks to see if you're diversifying value. And use partial regression to isolate what's driving gains. Capability improvements, context quality, or workflow redesign.
In LLM ops, measure guardrail violation rates, schema adherence, pass at K for tool calls, and mean time to human intervention. Maintain golden datasets and canary tasks in production. Offline evaluation plus shadow mode catches regressions before they hit your customers.
Explore bandit-based prompt selection to adapt in real time, and if you have the data, fine-tune with preference learning like DPO to align outputs with your domain norms. Just keep your evaluation harness strict, or you'll overfit to your metrics and miss real-world brittleness. Give us a non-obvious, maybe slightly contrarian insight the data implied but didn't shout.
Here's one. The answer isn't ever longer context windows, it's smaller, cleaner context. Organizations should invest in canonicalization and compact evidence graphs. The elasticity result says piling on tokens has diminishing returns, so win by curating, not by shoveling.
I agree with nuance. Large contexts still help when paired with hierarchical retrieval and re-ranking, but we can further reduce cost with blockwise caching and pointer-based references. The goal is high relevance, low redundancy context that the model can truly attend to.
From the business seat, it just works beats it's configurable. Vertical context packs, pre-curated policies, templates and evaluators shorten time to value. Customers don't want a search stack, they want a resolved decision with provenance.
That favors incumbents who can afford curation. We should consider shared industry utilities, standards for schemas, retrieval interfaces, and audit artifacts, so small firms aren't locked out by context engineering fixed costs.
Another underplayed story in the report, education and science usage are rising. What's the structural signal here?
Education climbed from roughly 9% to over 12% of usage, science from about 6% to 7%. Knowledge synthesis tasks explain, compare, derive, fit the model's strengths. The release of search in a research mode appears to have opened new workflows rather than merely accelerating old ones.
Technically, research modes that ground claims with citations and let users traverse sources reduce hallucinations. Systems are adopting confidence scoring, claim-level verification, and side-by-side evidence panes. The upshot is a virtuous loop between model reasoning and human scrutiny.
We've seen an EdTech rollout where interactive content built with live artifacts, code, data, assessments, boosted course completion by over 20% and cut authoring time almost in half. Importantly, instructors remained in the loop to enforce pedagogy and local standards.
With 77% automation in API usage, how do teams avoid quality drift when humans aren't constantly in the loop?
Design contracts, strict JSON outputs, pedantic validators, unit tests on outputs, and build red team canaries into production. Pair that with drift detectors on embedding distance and guardrail anomaly alerts so you can auto-throttle or fall back before users feel the wobble.
Add self-checking, multi-pass critiques, evidence consistency checks, and early stopping when confidence is low. Yes, it adds small latency and cost, but the failure rate plummets, and downstream rework is far more expensive than another 100 milliseconds.
And put the governance spine in place, risk registers, ownership for model changes, and clear escalation paths. The threshold for human review should be tied to impact, not developer convenience.
Let's circle back to emerging markets. Beyond the first-order story of low AUI, what are the second and third-order effects leaders should anticipate?
Two trajectories are plausible: divergence if productivity gains compound only in high AUI regions, convergence if AI becomes the great teacher, augmentation-oriented programs, subsidized access to research-grade features, and pragmatic workplace training could shift the equilibrium toward catch-up.
Expect partial reshoring of routine digital work. BPO providers will need to climb the stack, embedding domain playbooks, compliance wrappers, and multilingual retrieval to maintain edge. We're already seeing clients prioritize providers with proprietary knowledge graphs over pure labor arbitrage.
Infrastructure-wise, mobile-first copilots with robust speech interfaces and intermittent connectivity modes can serve vast user bases. Edge caching plus periodic sync allows high-utility flows without constant bandwidth.
Standards help reduce friction. Multilingual embeddings, transliteration-aware tokenizers, and code-mixed retrieval improve performance in real-world linguistic settings. Lowering this barrier is a technical lever for global inclusion. To close us out, I'll stitch the threads. AI adoption is fast and concentrated. Enterprise deployment through APIs is automation-heavy, capability-driven, and constrained by context curation more than price. High AUI regions diversify and collaborate more, while low AUI regions delegate more, raising both opportunity and equity questions.
The strategy signal is clear. Treat adoption as an S-curve you can bend, invest in context quality, measure automation share by process, and broaden the set of high-fit tasks. Otherwise, the power law concentration will trap you in the head of the curve.
Technically, build retrieval that respects your ontology, validates structured outputs, and instrument everything. Success is a function of orchestration quality as much as model quality.
Operationally, stand up vertical context packs, define clear exception pathways, and retrain teams around judgment work. The prize is double-digit throughput and cycle time gains without sacrificing trust.
Public leaders should scale access, skills, and safe demand. With thoughtful policy, we can turn early concentration into broader diffusion and avoid deepening divides.
And under the hood, win by shrinking context, not by starving it, but by making it crisp, canonical, and explainable. When context is a product, automation becomes dependable.
That's a wrap. The Index's open data gives everyone a chance to test these claims, and we'll be here to translate the next wave into action. Thanks for listening, and keep building with rigor, not just speed. Before we sign off, let's do a rapid end-to-end synthesis. What this index really means for leaders today, and where to place your next bets.
Big picture, adoption is fast and concentrated, mirroring classic diffusion but on a compressed clock. Build an internal usage index, your own AUI. Track automation share by process and the genie of task concentration, then deliberately expand beyond coding into education, science, and admin, where the report shows rising traction to avoid getting stuck in the head of the power law.
Technically, the new baseline is precise context plus predictable execution, hybrid retrieval with multi-stage re-ranking, schema-validated JSON outputs, guardrails and canary tasks, token KV caching, and bandit-driven prompt selection. Aim for single-shot program synthesis with self-checks and deterministic tool use, and you'll convert directive demand into dependable automation.
Operational playbook, ship vertical context packs, policies, templates, evaluators, design exception pathways first, and move 3 high-volume processes to AI drafts, human ratifies, system executes. Manage by flow metrics, first-pass acceptance, exception rate, cycle time, and remember the report's weak price elasticity. Capability fit trumps unit cost.
Strategy and policy must bend the curve. Invest in connectivity, skills for AI-augmented workflows, and demand-side pull via procurement. Standardize schemas and audit artifacts so smaller firms aren't priced out by context engineering fixed costs. Watch for the contrarian risk that governance overhead can reprice architectures and shift the cheapest to audit stack into the lead.
The surprising constraint is context, not compute. Longer inputs yield sublinear output, about 0.38 elasticity, so curate rather than dump. Build a domain ontology, canonicalize facts, tag evidence, enforce retrieval budgets, and run drift monitors with version prompts and golden datasets. When context becomes a product, automation becomes reliable.
Highlights in one breath. Usage is clustering in high-income regions and coding-heavy tasks. Enterprise API work is 77% automation and strikingly price-insensitive. Directive interactions are rising while creation outpaces debugging. Complex tasks are gated by context quality, not just model quality. State-of-the-art execution means hybrid retrieval, structured I/O, self-verification, and guardrails. Practical next moves. Business leaders should pick 3 processes where value of automation exceeds context and exception costs. Stand up vertical context packs and reskill teams around judgment and audit. Technology leaders should instrument retrieval and output validation, measure guardrail pass rates and exception funnels, and treat LLM ops like SRE for cognition. Forward look. Unequal geography isn't destiny. Targeted infrastructure, skills, and public demand can flip emerging markets from automation only to collaborative augmentation, while enterprises that master context curation will climb out of the head of the power law into broader productivity. As an old ops adage goes, amateurs talk strategy, professionals talk logistics. In AI, logistics is context, and those who standardize their rails will run more trains. Thanks for joining us. Explore the open data, and we'll be back to translate the next wave into decisions you can ship. Tag a peer who challenges your thinking and swap your top 2 takeaways from this discussion.